Okay, I welcome you to this week 2 online facilitation of the course PHY 205. That is Introduction to Space Physics. Once again, I am Dr. Cyril Gwaza Afoy, an Associate Professor of Applied Geophysics. So we'll be looking at satellite systems. Satellite systems. The main content of this module is fundamentals of satellite systems, the basic characteristics of satellites, improved space platforms and launching of satellites. Then we'll also look at transponder, spacecraft and repeater, spacecraft communications, and spacecraft antennas. The objective, at the end of this unit, you are expected to be able to, one, explain the fundamentals of satellites. Okay, you should be able to explain the fundamentals of satellite systems, and you should be able to list the basic characteristics of satellites. And then you should be able to define the term transponder. Then you should also be able to discuss the principles of spacecraft and repeater, and then list and explain the various types of spacecraft antennas. So let's introduce this. Satellite systems have evolved into an everyday commonplace thing. Nearly all the television coverage travels by satellite. Today, reaching directly to the home from space. You can see that by through the phones we use for communication these days, and even cable satellite used in our television and others. Even in the age of wideband fiber optic cables and the internet, satellites still serve the basic communication needs of majority of countries around the world. For example, domestic satellites have greatly improved the quality of service of the public telephone system and brought nations more tightly together. Okay, that is why you can just stand here and call a brother or a friend in the US or UK or anywhere around the world, and you'll be able to contact and communicate with the person. You know, that is one beauty of satellite communication and satellite systems. Then what are the fundamentals of satellite systems? One, satellite communications no longer a marvel of human space activity, because it evolved into an everyday commonplace thing now. Nearly all television coverage travels by satellite, today reaching directly to our television at home. Now, even in the age of wideband fiber optic cables and the internet, satellites still serve the basic telecommunication needs of a majority of countries around the world, as I said. Okay, satellites are adapting to development in multimedia information and personal communication with the cost of one-way and two-way Earth stations now within the reach of many potential users. Okay, now a unique benefit has developed in the area of emergency preparedness and response. Now that is in terms of emergency, in terms of flooding, in terms of any emergency, satellite can easily aid the response team to find the solution, whatever the problem is. Now, what are the basic characteristics of satellites? A communication satellite is a microwave repeater station that permits 2 or more users with appropriate Earth stations to deliver or exchange information in various forms. Now, a satellite in a geostationary Earth orbit, GEO, that's Geostationary Earth System. Take note of the acronym GEO. It means Geostationary Earth Orbit. Revolves around the Earth in the plane of the equator once in 24 hours, maintaining precise synchronization with the Earth's rotation. There are 2 other classes of 24-hour orbits: the geosynchronous orbit and the highly elliptical synchronous orbit. Both involve satellites that appear to be stationary relative to a fixed point on the Earth. Now, a given geo satellite has a coverage region illustrated by the shaded oval within which Earth stations can communicate with and be linked by the satellite. That's if you look at the figure, the image there, you will see round in the middle, just close to the Earth. You see an oval shaded portion there, within which the Earth stations can communicate with and be linked by the satellite. Then the satellites are in orbit revolving around the Earth. Okay, it's a system of 3 geostationary communication satellites. Provides nearly worldwide coverage, right? Let's proceed. Now you can see that this is the better picture. Then the JCSat 2A satellite operated by Sky Perfect JSat and built by Bowen. Okay. So now we've been talking about transponder. What is transponder? The satellite communication industry has long used the term transponder in reference to a defined RF channel of communication within the communication payload. Now, the term itself is a contraction of 2 terms, 2 words, which is transmitter and responder. Okay, so originally referring to a single frequency repeating device found on aircraft. The purpose of the aircraft transponder is to add the identification of the aircraft and actively enhance the power to be reflected back to the radar transmitter. A satellite transponder is entirely different because it is more of a transparent microwave relay channel, and also taking into the account the need to translate the frequency from the uplink range to the downlink range. Okay, let me take that again. Okay, a satellite transponder is entirely different because it is more of a transparent microwave relay channel, also taking into account the need to translate the frequency from the uplink range to the downlink range. Now, the transponder then is a combination of elements within the payload. Okay. Now, spacecraft and repeater. We need to understand what spacecraft is and what a repeater is. Now, a spacecraft is the actual piece of hardware that is launched into orbit to become an artificial satellite for the purpose of providing a radio repeater station. Okay, let's take that again. A spacecraft because you need to know this. You won't escape it during the exam. The spacecraft is the actual piece of hardware that is launched into orbit to become an artificial satellite for the purpose of providing a radio repeater station, right? Now, the physical elements that a communications spacecraft comprises can be divided into two major sections. The first one is the communications payload, or just the payload, containing the actual radio communications equipment used for reception and transmission of radio signals, and the spacecraft bus, which is referred to as the box, which provides the supporting vehicle to house and operate the payload. Let me take that again. The physical element that the communication spacecraft comprises can be divided into two major sections. The first one is the communications payload. Then the second one is the spacecraft bus. Okay? The emphasis in this chapter is on the requirements and specification of the payload and how the general types of hardware designs can meet those requirements. Hope we are together. Spacecraft communications, just to simplify this, the design, manufacture, and operation of the communication satellite are no simple matter, complicated by the fact that it must survive the rigors of launch and deployment in orbit, followed by many years of satisfactory operation without physical intervention by human beings. Okay? Now, in layperson's terms, we assume that a certified repair person cannot travel to orbit to repair or reconfigure a satellite. That is certainly the case for geo satellite. That's geostationary Earth orbit satellite. But it is not economically feasible, even for large constellations of LEO satellites. It is critical that the payload and the bus work hand in hand to establish a highly efficient radio repeater on a stable space platform. Now, the satellite itself has the ability, while in orbit, to make some repairs, maybe through the IT station on the Earth base station. Okay. Now, spacecraft antennas. We have the horn antennas, horn antennas. If you look at the figure there, you see a diagram. The diagram is a common type of horn antenna called a pyramidal horn. Just it has the shape of a pyramid. Okay. Now, pyramidal horn in which the end of the waveguide is flared outward in the shape of a pyramid or a cone. Okay, a pyramidal horn antenna is that which the end of the waveguide is flared outward in the shape of a pyramid or a cone. Now, the dimensions of the opening are in direct proportion to the wavelength and are dictated by the shaping of the far field antenna pattern. Now, the pyramidal horn is well suited to linear polarized systems because of the natural straightness of extending rectangular waveguide. Okay? The standard waveguide mode of propagation is maintained, resulting in a symmetrical main loop pattern and little or no cross-polarized component. In contrast, the conical horn flares from either circular or square wave guide. In the latter case, there must be a square to circular transition into a circular aperture. Now, this type of horn is best suited to dual or CP, while the LP performance of the rectangular horn is superior. So I'll be giving you a self-assessment exercise. You also see it on the e-learning portal on the course page. Now, for your self-assessment exercise, explain the basic characteristics of satellites. Explain the basic characteristics of satellites. I expect you to do this. In case you have any problem, you let me know. In conclusion, you have learned in this unit that a communication satellite is a microwave repeater station that permits 2 or more users with appropriate earth station to deliver or exchange information in various forms. Let me take that again. In conclusion, you have learned in this unit that a communication satellite is a microwave repeater station that permits 2 or more users with appropriate earth stations to deliver or exchange information in various forms. Okay, and you have also learned that even in the age of wideband fiber optic cables and the internet, satellites still serve the basic telecommunication needs of a majority of countries around the world today. Okay, now let's try to summarize everything we have looked at in this unit of satellite communication. In this unit, you have learned that all television coverage travels by satellite. Today, reaching directly to the home from space. And that we can see that in our televisions, in the phones we use for communication. A satellite in a geostationary Earth orbit, GEO, revolves around the Earth in the plane of the equator once in 24 hours. Once in 24 hours. Take note of that. Maintaining precise synchronization with the Earth's rotation. Okay. There are 2 other classes of 24-hour orbits. That's the geosynchronous orbit and the highly elliptical synchronous orbit. I said what? There are 2 other classes of 24-hour orbit. That's apart from the geostationary Earth orbit. We have the geosynchronous orbit and the highly elliptical synchronous orbit. Now, the purpose of the aircraft transponder, as we have seen, is to add to the identification of the aircraft and actively enhance the power to be reflected back to the radar transmitter. Okay? A spacecraft, we have also seen that a spacecraft is the actual piece of hardware that is launched into orbit to become an artificial satellite for the purpose of providing radio repeater station. This is a summary, and I believe each one of them, you have noted them, and you understood what we have done. Now, satellite networks. Satellite networks. In introduction, the majority of satellite operations depend on the reliable transfer of telemetry and command data between the actual Earth stations that are in direct contact with the orbiting satellite, and the control of spacecraft subsystem, where the full range of technical and management functions are performed. Okay, Now, those links, which can employ both terrestrial and satellite networks, usually satisfy the data throughout and quality of services. Okay, objectives of the overall satellite control system. Let me take that again. Those links, which can employ both terrestrial and satellite network, usually satisfy the data throughout and also the quality of service, QoS, and objectives of the overall satellite control system. Okay. Now for this unit, we are expected that at the end, you should be able to achieve the following objectives. One, you should be able to understand the various satellite orbit configurations. You should also be able to explain the architecture of satellite networks. You should also be able to list and explain the three generic forms of satellite connectivity. And then you should also be able to define the term connectivity. So at the end of this unit, you should be able to understand and explain what I just said are the objectives of the unit. Now, satellite orbit configurations. Having already introduced the concept of geo and non-geo satellites, we can now examine some of the technical particulars, particularly the behavior of a satellite in Earth orbit follows Kepler's laws of planetary motion, which can be restated for artificial satellites as follows. Okay, one, the orbit of each satellite is an ellipse with the Earth centered at one focus. That is the Kepler's laws of motion. The first Kepler's law of motion says that what? The orbit of each satellite is an ellipse with the Earth centered at one focus. And then the second Kepler's law of motion, which is also known as the laws of areas, says that the line joining the satellite and the center of the Earth sweeps out equal areas in equal time. The area is bounded by the arc segment of the orbit and two lines that extend from the center of the Earth. Okay? Now, the third Kepler's law of motion states that the square of the period of a satellite is proportional to the cube of its mean distance from the center of the Earth. Let me take that again. The third Kepler's law of motion states that the square of the period of a satellite is proportional to the cube of its mean distance from the center of the Earth. That relationship is plotted in the figure below to give an idea of the relationship between altitude and orbital period. Now, lower Earth orbit, that is LEO, L-E-O. L-E-O actually means lower Earth orbit systems employ satellites at altitudes ranging from 500 to 1,000 kilometers. Let me take that again. The lower Earth orbit, LEO. The lower Earth orbit system employs satellites at altitudes ranging from 500 to 1,000 kilometers. Over that range, the orbit period is between 1.6 and 1.8 hours. The higher orbit resulting in a slightly longer period of revolution. Two, and also the reason for that small change in period is that it is the distance from the Earth, from the center of the Earth, that determines the period, not the elevation above sea level. Let's take that again, and please note it. The reason for that small change in period is that it is the distance from the center of the Earth that determines the period, not the elevation above sea level. Okay. Now, if we look at this image, this figure, we notice that we have the LEO, the LEO system, the MEO system, and the GEO system. Now, the three most popular orbits for communication satellite are the LEO, MEO, and GEO. They are the popular orbits for communication satellites. Now, the respective altitude ranges are 500 kilometers to 1,000 kilometers for LEO orbit, followed by 5,000 kilometers to 1,000 kilometers for MEO, and 36,000 for GEO. Please note this. I can ask you to differentiate between the LEO, MEO, and GEO orbits for communication satellites. And in terms of their ranges, altitude ranges, you should be able to do that. Then only one orbit per altitude is illustrated, even though there is a requirement for multiple orbits for LEO and MEO satellites to provide continuous service, that is satellite service. Satellite architectures. Any communications satellite performs the function of a microwave relay in a telecommunications network. The most basic type of relay is the bent pipe style of satellite, which does not alter the nature of the transmissions between Earth systems. The Earth stations, in this case, must organize their transmissions to efficiently use the satellite's repeater resources and to allow the various points on the ground to transfer or exchange the required information that then determines the basic network structure for the particular application. Okay? The general features of satellite networks. The property which a satellite network provides via links between users is called connectivity. Okay? I can ask you what is defined connectivity. You should know that connectivity, the property which a satellite network provides via links between users. What did I say? I said connectivity is a property which a satellite network provides via links. Now we have uplink, downlink between users. It's called connectivity. Now the three generic forms of connectivity are point-to-point, point-to-point, point-to-multipoint, and then multi-point interact. Let me take it again. The three generic forms of connectivity are point-to-point, point-to-multipoint, and multi-point interact. So I expect you to know this, which you should not forget. You should always know that the three generic forms of connectivity are point-to-point, point-to-multipoint, and multi-point interact. Okay? Now the self-assessment exercise is define the term connectivity. You should be able to define it now. I told you what connectivity is. And you should list and explain the three generic forms of connectivity. Conclusion. You have learned in this unit the various satellite orbit configurations, satellite network architectures, and general features of satellite networks. Summary. Let's summarize what we have learned so far. In this unit, you have learned that the behavior of a satellite in Earth orbit follows Kepler's laws of planetary motion. You have also learned that lower Earth orbit LEO system employs satellites at altitude ranging from 500 to 1,000 kilometers, 500 meters to 1,000 kilometers. 500 kilometers to 1,000 kilometers. Okay. The altitude of a medium Earth orbit, MEO, medium Earth orbit, is around 10,000 kilometers, a period of about 6 hours. Now, the most basic type relay is the bend pipe style of satellite, which does not alter the nature of the transmission between the Earth stations. Okay? We have also learned that the property which a satellite network provides via links between users is called connectivity. The three generic forms of connectivity are point-to-point, point-to-multipoint, and multi-point interactive. I'll give you a TMA, tutor mark assignment. You will see that on the portal, on the course page, the e-learning portal platform. So you check and ensure that you do them for this week and the one we did in the first week. Okay, so wish you all the best. I wish you all the best, and I hope I'll see you the same time next week. And if you have any problem, my email is there. Send an email to me, and then we'll discuss in the next class, online class. Wish you all the best, and make sure you do all the self-assessment exercise and also the TMA that I will give you. I'll send to the portal e-learning page. See you next time. Wish you all the best.